Hello and welcome to our video on unit testing and AutoSAR software component. Do you have an AutoSAR Classic component which models calls to basic software services and want to achieve coverage of the component? Well, then this video is for you. In this video, we will demonstrate how you can use Simulink Design Verifier to analyze your component at a unit level. My name is Alok and I am a developer for the Simulink Design Verifier product at The MathWorks. Here is a throttle position integration model which integrates two throttle position sensor components and a throttle position monitor component. These components contain calls to basic software services. The sensor components take a raw throttle position sensor value and convert it to a percent value, whereas the monitor component takes the percent values provided by the sensor components and decides which signal to pass through. Now, suppose you want to generate input test vectors at unit level for the monitor component. To do so, first we will open the Design Verifier pane on the Simulink toolstrip, select the component under test, and then run Design Verifier analysis. As you might know, to simulate the AutoSAR component that calls basic software services, we need to insert reference implementations of the corresponding services. Simulink Design Verifier achieves this by generating an analysis harness which contains Simulink functions that define these services. A quick look at the harness indicates these functions being defined such that they output any possible value within the supported range of the output data type. These values are controlled by the automatically inserted root level inputs which are driven by the generated test cases. Another thing to note here is that multiple calls to these functions within a single step would return the same values. Coming back to the analysis, you can see that when the software completes analyzing this harness, the results summary window displays that the software identified 18 coverage objectives for the component and was able to generate test cases that satisfy all these objectives. These generated test cases get saved in a MAT file by default, but you can also choose to save the test vectors in a test harness by creating a harness model which uses a signal editor block containing scenarios that are comprised of the generated test cases. Alternatively, if you have a Simulink test license, you can also choose to export the test vectors to new test cases automatically created in the Simulink Test Manager. This way, you can build your test suite comprising of test cases for different components of your system model. Do you know that generating input test vectors is not the only supported analysis mode? Design Verifier can also identify design errors and prove requirements compliance of your component model depending on the analysis mode selected. So, in this video, you have seen how to generate unit tests using Design Verifier for a component model which implements calls to basic software service interfaces using blocks from the AutoSAR block set. But you can also perform similar analysis when you have a Simulink model created by importing an AR.XML file. That's cool, isn't it? Additionally, you can also use Design Verifier to generate test input scenarios for back-to-back testing to ensure equivalence between models and their associated code. To learn more, you can visit our Simulink Design Verifier product page on mathworks.com. I hope you all enjoyed this video. Thank you very much for your time.